All right, gang, welcome back, welcome back. So, graphing other trig functions. Now, we're splitting this up into two videos, so that way it's not too overwhelming and whatnot. So you guys can plan accordingly on how you get through them. So, as far as the cosecant goes, when we go to graph cosecant, the biggest thing to remember is that cosecant is the reciprocal of sine. So what we end up doing on this is we end up graphing sine, and then we do something called rip it and flip it. And I'll show you what that means here. All these places that have x-intercepts for our sine function, when we do our reciprocals, 0 becomes 1 over 0, and it becomes undefined. So this line that these x-intercepts go through, we call that the midline. So wherever that midline gets moved, we are going to essentially cut the graph there, and we turn those into asymptotes. So instead of having x-intercepts at those places, we will have asymptotes at those places. And instead of having our graph, our parabola, or our sine curve come back to the x-axis or back to the midline, we're going to open it up and make them be essentially parabolas going away from it. Now, realize there's some weird little things that kind of happen with our cosecant graph. If you notice, since it's the reciprocal, everything gets flipped before from the sine. So right here where I have my relative max for sine, this is no longer a relative max, it's technically a relative min. Even though in this down here, even though this was a relative min for sine, this became the relative max. Now don't get too caught up on the idea that the minimum value, the relative minimum value, is bigger than the relative maximum value. Remember, it's that first word, relative. Compare it to the values around it. On this parabola, which is the values around it, this is the lowest value of this parabola. It's not a parabola, but it's relatively close to one. This parabolic shape, it's the smallest value of this curve. This would be the largest value of this curve in between these two asymptotes. So what we're going to end up doing here is we are going to graph sine, and then we're going to rip it along the midline to create cosecant. Likewise, we're going to do that same thing here with cosine. We're going to, since it's the reciprocal of cosine, we're going to rip and flip cosine to get cosecant. And again, notice that kind of that weird coinkydink thingamajigger there. Notice these, our relative min and our maxes got switched again here. So these two values right here are the relative min. Because they are lower than the values around it. This right here would be my relative max because it's higher than everything around it. Another thing to think about here, and we can go back up to cosecant and you can see it as well. If you notice, this distance between my asymptotes, it's not the full length of pi. Now, it's not the full period length. The period length was 2 pi. So that's my period length. It's still 2 pi. But my distance between my asymptotes is not 2 pi. The distance between my asymptotes is always half of my period length. So the distance between my asymptotes is pi. And remember, this curve will keep going over and over again. So there's going to be an infinite number of asymptotes. There's an infinite number of relative mins and maxes. The other big thing, and I didn't point it out on cosecant, but I want to point it out here for secant, is that, and you can kind of see it down below here, there is no amplitude for secant and cosecant. Even though sine and cosine had one, there is none for secant and cosecant. And the reason being is my graph here will go up to positive infinity and will go down to negative infinity. They're going to go forever. So other than that, there's not a whole lot of changes. We're really going to graph it the same way that we graphed sine and cosine. Everything is pretty much going to be the same. So to begin with, let's see if we can't kind of play with this idea a little bit here and try a couple graphs. All right, so we're going to do essentially the same thing that we did before. So let me write out all the stuff we have to end up finding here. Now, this won't be everything, but it'll be a lot of it. Amplitude. We have our vertical reflection. It doesn't say that in directions, but it should have. Period. So the period length. Phase shift. Vertical shift. Our domain. Our range. And we'll put even, odd, and neither. Remember that even occurs when we have a relative min or max on the y-axis. Odd occurs when there's a 180-degree symmetry around the point of origin, around that point of 0, 0. Now, for cosecant and secant, we'll be able to tell if it's odd, not that cosecant or secant will have a point located at 0, 0, but that the sine or cosine graph that goes with it will have a point at 0, 0. So let's see if we can't play with this a little bit here. Now, again, all of our trig stuff is still going to hold true. Everything is still going to be the same. So we have our A, and we're going to have cosecant B times x minus c plus d. So all that stuff is still going to be the same, whether it's sine, whether it's cosine, and now whether it's cosecant or secant. So I still need to figure out my A value. In this case, it's 2. I don't have a B value, so I have nothing to factor out. So B is 1. My C value is pi over 4. And my D value is -1. So amplitude, your first instinct might be to go to absolute value of A again. Don't do that. There is no absolute value of A here for amplitude, right? Just remember on secant and cosecant, anything that goes to infinity or negative infinity will not have an amplitude because there won't be a min or a max, overall min or max. A vertical reflection. Apparently I don't know how to spell vertical. Verical. Apparently I still don't know how to spell vertical. Vertical reflection. All right, so, and again, this is still the same thing. Is A negative? If A is negative, there's a vertical reflection. If it's not, no vertical reflection. So in this case, my A value is a positive 2, so there is none. My period is still going to be 2 pi divided by the absolute value of B. So just like we said, sine and cosine, these are pretty much the exact same thing, just a couple little modifications. So 2 pi divided by the absolute value of B. Well, my B value is 1. So 2 pi divided by the absolute value 1 is 2 pi. My phase shift is C, and my vertical shift is D. So if my phase shift is C, that's pi over 4. So that means I'm going to go right pi over 4. So again, there's a lot of things I can do before I even get into the graph of it. Vertical shift, that's going to go down 1. There's a lot of things I can do, and I haven't even got into the graph of it yet. So now to graph cosecant, I'm going to graph its reciprocal. And the reciprocal of cosecant is sine. So think back to what those beginning values were for sine. Whoop. And we end up with x and y. So sine was 0, 0. Pi over 2, 1. And then we had pi and 0. 3 pi over 2 and -1. And 2 pi and 0. Okay, so that's still going to be the same. That doesn't change because we need to know cosecant for to be able to figure out. We need to know sine to be able to find cosecant. Now realize these values here, when x is 0, those would be the points that were on the x-intercept. So those are the points that are essentially on my quote-unquote midline. And so we'll look at that here in a second, how that's going to affect us here. But everything's still the same. So I'm still going to take my b value, and I'm going to divide into every x, and then I'm going to add c. So that doesn't change. I like how there's a lot of, we can learn things and learn ideas and principles and apply them into a whole bunch of different ideas. So that's not going to change. So that means my b value was 1, and then I'm going to add pi over 4 to it. My a value was 2, so I'm going to multiply y by 2. And then I'm going to add a negative 1 to it, so I'm going to subtract 1 from it. All right, so here we go. 0 plus pi over 4. Pi over 2 plus pi over 4 would be 3 pi over 4. Pi plus pi over 4 would be 5 pi over 4. 3 pi over 2, that's 6 pi over 4 plus pi over 4, that's 7 pi over 4. And 2 pi is 8 pi over 4 plus pi over 4, that'd be 9 pi over 4. And then we have our 0. We plug 0 times 2, it's 0 minus 1, that'd be negative 1. 1 times 2 is 2, minus 1 is 1. And then we end up with negative 1, negative 3, and negative 1. So now, notice those midline values, so where those zeros were, those midline values are now when y is negative 1. So that's going to come into play here in a second. When I do my axis, remember I count by whatever my largest denominator is, or a smallest denominator. In this case, all the denominators are the same, so that's not going to affect anything. So I'm going to graph this here. So here I go. 1, 2, 3. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And you have to label your graph. You have to label your axes. I have negative pi over 4 there. I'm going, there's 1, there's negative 3. And this is 9 pi over 4 here. So that way we all can kind of see where we're at. Now, realize, when I graph my sine graph, I'll go ahead and make that the red graph. Notice, I'm not going to fill in every single little thing. So pi over 4 in negative 1, that'd be right about here. Then I have 3 pi over 4 in positive 1. I have 5 pi over 4 in negative 1. 7 pi over 4 in negative 3. Oopsies. Should have gone over one more. 7 pi over 4 in negative 3. And 9 pi over 4. So you can kind of see where that midline is. You can kind of see a little bit about where that midline is. So here's that midline right over here. Oops, I was supposed to put the negative 1 there. So those are where the original x-intercepts were. So now, instead of being x-intercepts, those are going to be where my graph is going to have asymptotes. So I'm going to have asymptotes that go through those lines. And so my asymptotes will go through those lines. That green, wherever those old x-intercepts were after they got transformed, that formed my midline. So that's where I end up ripping my graph. Because again, remember, if we were to go through and connect these, this would be my graph of sine. Notice I'm just doing in parentheses or dashed lines there just so you can kind of see where sine is, because that's not the graph I'm graphing. What I'm graphing is cosecant. So I use sine to help me figure out where my asymptotes are in my relative mins and maxes. Then I make it so my curves go the opposite direction. The opposite direction. Now notice, I can keep doing my graph of sine if I wanted to. And because of that, if I keep doing my graph of sine, it'd be over here, right? That tells me then that my if I were to then go and take my graph from my cosecant graph, that'd be kind of coming over here. Notice I don't have my sine going through 0, 0, so it's not going to be odd. I don't have a relative extrema for my sine graph or my cosecant graph on the y-axis. So my graph here is going to be neither even nor odd. And I'll come back and look at the domain and range here in a second. The y-intercepts, this is when my graph, my x value is 0. Now this time it didn't work out pretty. I'm not going to have a pretty answer for my y-intercept. That's okay though. We're just going to evaluate the unit circle on this. So we have y equals 2 times the cosecant of negative pi over 4 minus 1. Now, pi over 4 is the same thing as 7 pi over 4. So cosecant of 7 pi over 4 is negative root 2 minus 1. So that means y is negative 2 root 2 minus 1. Now, that's not a very pretty y-intercept, but that is the hand we were dealt here. From there, we can figure out our asymptotes. Notice my period is 2 pi, so my asymptotes, they should be 1 pi away from each other. You can kind of see that they are actually going to be 1 pi away from each other. So my first asymptote showed up here at pi over 4. So that means my asymptote is going to be located at pi over 4 plus, instead of 2 pi n, it'd be plus pi n. That'd be my asymptote. From there, I have my relative minimum and my relative maximum. So my relative max, that's going to be located at the top of the hill. So where's that relative max at? Well, that's going to be right here. That's compared to everything else, that's the top of my hill. So that coordinate at that point is 7 pi over 4. And at negative 3. So we're going to add the period to it because it's going to happen over and over again. So the period is 2 pi. So that'd be 2 pi n. My relative min, that's going to be at the bottom of a valley. So where's the bottom of a valley at? That'd be right about here. That's the bottom of a valley right there. So what coordinate is that? And again, doesn't matter that the relative min overall is more than the relative max. It's what are they around it? What's close to it around it? So that's 3 pi over 4. It's the bottom of a valley. Relative max is when my graph goes from increasing to decreasing, or the top of a hill. My relative min is when my graph goes from decreasing to increasing, or the bottom of a valley. So that's plus 2 pi n. All right, so friends, now we can do the domain. So the domain is all real numbers except for the asymptote. So whatever the asymptote is, that's where my x can't be. So for my domain, it's whatever my x can't be. So that'd be pi over 4. So x can't be equal to pi over 4 plus pi n. So whatever the asymptote is, just change the sign to not equal to. For my range, I went from negative infinity to negative 3. And then also, and this just means union or together, and 1 to positive infinity. All right, friends. So you can kind of see the value for secant below. Go ahead and take a second. Remember that secant is the reciprocal for cosine, and then we'll come back and we'll deal with that one here in 1 second. That gave me a quick second there. My daughter brought me a Starbucks. Not too shabby. Oh, they got this new pumpkin cream cold brew that I am a big fan of, friends. I am a big fan of that. All right. All right, let's try this next one here then. Let's see how you guys did. So again, still that same thing. Now we're doing secant. So A times secant of B x minus C plus D. So I do need to go ahead and factor this one a little bit here. If I factor out that 1/2, so I do have a B value this time, x plus 6 pi. So that means A is -1, B is 1/2, C is -6 pi, and D is +1. All right, so now we're going to go through and figure out all the fun stuff. Again, what do we got? We have our amplitude. See if I can actually spell vertical right this time. Vertical reflection. We have our period. We have our phase shift. We have our vertical shift. We have our domain. We have our range. And then we have our even, odd, and neither. And then the asymptotes, the relative max and min, and the y-intercept we'll get here in a second. So again, like we said before, there's a lot of stuff we can do. Amplitude, you just better put does not exist or none as quickly as humanly possible. There is no amplitude for secant or cosecant. Vertical reflection, again, we're asking ourselves, is A negative? Is A negative? Well, A is -1. So in this case, is there a vertical reflection? You bet. Period. Does it have a period? Again, still 2 pi divided by the absolute value of B. So 2 pi divided by the absolute value of 1/2. Every time I say 2 pi, I always think of Tupac, but guy was a poet. Guy was a poet. Phase shift, we have -6 pi. So we're going to go left 6 pi. Vertical shift, we went up 1. So now we're dealing with, since it's secant is the reciprocal of cosine. So we're going to go ahead and deal with cosine then. These are the values I'm going to use. Cosine of x. Because that's what I'll rip and flip then to get my secant. All right, so we have 0, 1. Whoop. We have pi over 2 and 0. So that's a point on the x-axis originally. So that's going to be part of the midline. So pi is -1. 3 pi over 2 is 0. That's the other value for cosine that's on the midline. 2 pi and 1. So the midline values will be the second and fourth one. So I'm going to put a little M there to remind myself these are my midline values. So that's where I'm going to do my ripping and flipping at. All right, so Now we can go through and figure out the rest of these values here. So we have x divided by b plus c. I do like how we get to bring a first semester essential skill and bring it part of second semester. This kind of helps build off each other. All right, so in our case then, our b value was 1/2. So I'm going x divided by 1/2 plus a negative 6 pi. In other words, x divided by 1/2, that's the same thing as 2 times x. So 2x minus 6 pi. So that's what I'm going to do to all my x values. My a is -1, so y times -1 plus d, so plus 1. Now, these actually are going to be halfway decent little numbers to kind of deal with here. 0 times 2 would be 0. Minus 6 pi, that'll be a negative 6 pi here, friends. Pi over 2 times 2 is pi minus 6 pi, so that's negative 5 pi. And if I keep going through here, I'm going to get negative 4 pi. Negative 3 pi. And negative 2 pi. If I take my y values, 1 times -1 is -1, plus 1 is 0. Here's my midline value, it's going to be 1. So all my y values of 1, those are my new midlines. Then I have 2, and then I have 1, and I have 0. All right, so now we got our cosine values. We're going to go ahead and graph cosine, and then we'll go ahead and finish up and rip it and flip it to get my secant. One, 2, 3, 4, 5, and 6. And I'm going 1, 2. Notice I always add 1 every quadrant, just kind of make, or every part of the axis, just make sure it's all nice and balanced. So that's going to be pi. I'm counting by pi here on this one. This is negative 6 pi. I have -1 and I have 2. All right, let's graph the dumb thing. And again, I'm going to use, for my cosine, I'm going to use really small points for it because this is not the actual graph I'm graphing. I'm graphing secant. I'm just using cosine to help me out. So secant would look like this. And you can see where the midline values would be. We said the midline values will be here at the second and fourth value. So those midline values, this is where I'm going to end up ripping my graph. So any point on that midline will become my asymptotes. So I have an asymptote here when x is -5. I have an asymptote here when x is -3. Which means I'd also, if I really wanted to, I'd also have an asymptote here at -1 as well. I mean, and I'd have another one here at +1. I could just keep going on forever. So whatever value is not on the midline, I'm going to start that value and I'm going to go away from the midline. I'm going to use that to build my parabola-ish type shapes. I go away from the midline. I go away from the midline. And you can kind of see how if I wanted to, I could keep going over here to go away from the midline. Likewise, I could come in here. Ooh, looks like I'm going to have a y-intercept at 2. Even more importantly, that is a relative min on the y-axis. So we'll be dealing with that here in a second, looks like. So y-intercept. So I'm going to have plug 0 in for my x value and see if I can't figure out where my y-intercept is. So 1/2 times 0 plus 3 pi. plus 1. So y equals a negative secant of 3 pi plus 1. So secant of 3 pi, that is going to be negative 1. So I get y equals negative times the negative 1 plus 1. And yeah, I thought that might be 2. So 1 plus 1 is 2. I have a y-intercept at 0, 2. So if I were to keep this thing going, I'd have a y-intercept at 0, 2. My isotopes. So I just got to find one point that was on the midline. So the first one I got was negative 5, so I'll use that. So my asymptotes then are at negative 5 pi. And then I do half of the period length. So if the period was 4 pi, half the period length would be 2 pi. Now the relative min and max. So the relative min, that'd be right here, the bottom of a valley. It's when my graph goes from decreasing to increasing. So that is when at the point negative 4 pi and 2. So negative 4 pi and 2. But remember, got to add my period to it. So plus 4 pi n, because this graph will go on forever. Then I'm going to find a relative min. Here's a relative min right here. I could use either one of these. It doesn't matter. I could have used negative 6. I could have used negative 2. Whatever makes the most sense to you. I always go with whichever one is first in my table. It doesn't matter. Whichever one comes first on the left. Doesn't matter. And this is a relative min because this is where the graph goes from increasing to decreasing, or it's the top of a hill. So plus 4 pi n. So we can deal with the rest of it now. My asymptote is at negative 5 pi plus 2 pi n. That means my domain is every value but that. So just don't let x equal the asymptote. Let's see, my range went from negative infinity to 0. And then it went from 2 up to positive infinity. And when we brought our graph over here, notice we had a relative extrema on the y-axis. Therefore, our graph is even. Relative extrema on the y-axis is even if it's rotational 100-degree symmetry through the point 0, 0 through the origin, then it's odd. All right, friends, well, that's cosecant and secant. So that's the first half of our other trig graphs that we have, and we'll talk about the other ones here in a little bit.